Hello, welcome to the Machine Learning at Home. Today I will speak about clustergrams. Clustergrams, as you can see from the name, are related to the cluster analysis. But what is it and how it is related? It is better to see practically. Clustergram is a plot, so let us make the plot. First of all, I need to load my own package. Library, Shipunov. Please be sure that you have the latest version. It's important today. So it should be version 1.15 or maybe later. So this is downloadable and installable in a common way as you typically install our packages. As you load it, Shipunov version 1.15 or later, you can now start with clustergrams. But first, we need to create some data. I will use artificial data at first. So first of all, I will freeze random number generator with set seed command, for example 250. It's important that all results in my screen and on your computer should be similar. This is why I'm using set seed command. And then I will create artificial data, call it AA, and it will be matrix of random numbers. So our norm is a function which allows to create random numbers, and I will need 20,000 random numbers, and will split them in 100 rows. Just a question, how many columns? Think of it. So then I will work with a clustergram. So clustergram is a function, clustergram, and it will use the data, and also it will use the maximal number of clusters. In that case, there are too many columns, by the way, how many? And these columns should be restricted with less number of clusters, otherwise function will work too slow. So I will use max number of clusters, max CL, equal to 5. Okay, and then we'll look on that clustergram. Okay, something interesting appeared. This is a plot. Plot of what? So first of all, we assume that data has two clusters, and then we plot these two clusters as two dots and calculate distance between these clusters. So distance between this lower dot and this upper one is the distance between two clusters. Then we assume the data has three clusters and also show the distance between them. Then we assume the data has four clusters and show distance with them, between them, and 5 clusters, and so on. So as you see, the data shows some completely tangled output. So this is a, I would say, bad clustergram, which to me is clear indication that data is completely random. So as you see, practically clustergram allows you to understand, is your data random or it has some order? How the good clustergram looks? Okay, let us make a good clustergram. By the way, how many columns? So, and call AA 200 columns. So function that if you do not allow use max CL equal to 5, function will try to calculate number of clusters up to 100. It will be very slow. Anyway, so with that size of data, we need restrict number of maximal clusters. Now let us make the good data and a good clustergram. For simplicity, I will keep the same name AA. I simply modify my AA data. First of all, I will use first 60 rows and will transform them. So we'll make this first 60 rows result of summation between the previous number and, let us say, 0.7. So we'll increase the value in every cell on first 60 rows by 0.7. Okay, and then I will use first 20 rows and also increase the value in each cell by 0.4. Yes, sorry, I made a mistake. 120. Okay, so this will be better. And now, as you see, my data should have 3 clusters in it. First cluster is row 1 to 60. Second cluster is row 1 to 20. And a third cluster are rows which we didn't modify, rows from 61st to 100, because we specify that our data must have 100 rows. Let us see how clusters look in that case. So we modified original data, so we can simply repeat the same command, clustergram AA max CL equal to 5. But picture should be different, I think. Yes, so this is a clustergram of good data, data which has order in it. So you see, after the cluster number 3, situation is slightly more tangled, but still quite clear. Actually, the point from which this tanglization, if you can say that, starts to appear is a point which is indication of actual number of clusters in the data. So information increases up to 3 number, after number of clusters equal to 3, and then information kind of start to be more random, more chaotic, more entropic, if you can say that. So 3 is likely the true number of clusters. Of course, we cheated here because we know that we created 3 clusters. But if you do not know how many clusters are in your data, you can look on clustergram, see where information start to be more chaotic, more tangled, and that will probably nearby the actual number of clusters. So as you see, clustergram has 2 very good things. First of all, it allows you to understand, is your data is clusterizable? Does it contain any order in it? It's a very good idea, right? And then it also will show how many groups are present within your data. Of course, this is with some approximation, but again, this is a good thing to know. And let us use now, as a third example, some real data. Of course, I will use iris data. So let us make a clustergram for iris. And we, of course, do not use column number 5, which contains species name, and for a bit of diversity, make maximal number of clusters 7 in that case. And let us see what is going on. Okay, that's exactly what I tried to explain. Look on that data. Before cluster number reaches 3, it is perfect. Then it starts to be more and more tangled, especially in the upper part. So lower cluster is almost intact, whereas the uppermost part of the plot is very tangled. So if you know the nature of iris data, it will clearly say exactly what you already know. Because in this iris data, one cluster is very separate from 2 others, and 2 other clusters are really mixed together. So 3 number of clusters is the answer, and you can see that. But then everything is very tangled between 2 last clusters, and the first one is almost intact. So it's very interesting to see that in clustergram. So clustergram can also reveal some more interesting interaction between clusters, if you like to research in that way. I made a clustergram function on the basis of existing in internet some functions, but I added here also bootstrap and also different ways of clusterization. So if you simply use a help from clustergram, you will see some good examples of how to use clustergram in a more extended way. But today it is, so I finishes my story about clustergram. Thank you very much.